Hi, Leah. Thanks for sending me the screenshot of that problem to remind me about what it was. So I've got a little bit of fresh eyes today, and I figured out what they're doing. Just to give you, like, let's just set it up a little bit here. If we have our normal curve, that's not a very good normal curve, but you know what it should look like. When it says the middle 25%, what it means is we're gonna like make this part of it be 25%. So that's what I couldn't figure out from the question yesterday, right? But now I understand what they're talking about. And so each section to the right and the left of the mean would be 12.5%. And so here that would be 12.5% as well, okay? So that's really important because what we're trying to figure out is the p-value on both of these lines that I just drew. So if we're at 0.5 at the mean, because we're 50% of the way along the curve, and then if we go another 12.5, then we're at 0.625% of the way along the area of the curve. And if I'm at 0.5 and I go back by 12.5, then I think that puts me at 0.375% of the way along the curve. So these values are p-values, like they're percentage or probability values, right? And we're used to using the RStudio to give us those p-values. But then I discovered that if you go into R, let me just bring this, let me bring this picture down here because I went into R and I took a picture. Why won't that come? Okay, well, let's just make it bigger for now. I took a picture of what I got when I put this into R. So what I found out is that if you use the Q-norm function, but you don't put in like your x value and then your mean and then your standard deviation, you know, comma, comma, comma sort of thing, if you put in your p-value, then what it does is it spits out the z value. So you don't need to use those charts that we were talking about. This is how R does it. And it's a lot faster than looking it up on the chart, and it's a lot more accurate because look at the number of decimal places. We've got 7 decimal places there for our z value. So if we put in 0.375, we get this for our z value. And if we put in 0.625, we're going to get the positive for our z value because it's symmetrical, right? So it's like to the left or to the right of the median, but it's equal distance. And so the z positive value, the other one, is going to be just 0.3186, blah, 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 okay? So what that does is it gives us two z values that we can use to solve this problem. So I'm going to show you, I can't make this small again, there we go. Oh, I made it too small. Alright, so I'm going to show you how we use those values. The other part of the information in the question is that the values of the 6 and the 12. And so what they're basically saying is that this is 6 and this is 12. So we're just looking for the values above that. And I'm trying to circle that, and it won't do it for me. There we go, just above that. So we're looking for those values in the curve. And so here's how we set it up. We say that either mu plus the z value that we found for the positive one times sigma equals 12, or mu minus, because of the negative z value that we found for the 0.375, times sigma equals 6, because that's our interval. It's in between 6 and 12, right? And so basically what we've done is created a system of linear equations. I don't know if you remember, you know, solving linear equations like this by elimination, that if you just add these equations sort of down the columns, then you'll get 2 times mu, and this is 0, and this is 18. And so it gives us mu is 18 over 2, which is 9. So now we have our mu value. And so I won't bother calculating it for you, but you can see how to do it. you take this 9 and you're going to stick it back into one of the equations. Oops, not there, sorry. Not there. You're going to stick it back into one of the equations for mu and solve for sigma. And that'll give you your mu and your sigma for that problem. So the one for number 7 that we were working on together last night, that's actually very, very similar. I'm going to do a video for that one as well. But it's the same idea. For those percentiles, you're going to convert them into the p-value. So a percentile of 5% would be 0.05. And you look up the z value for that. And then you do the same with the 75th percentile. That's 0.75. Look up the z value for that. And then you can solve for sigma and you can solve for mu. And I'll send you a video for that anyway, so I won't confuse you with 2 questions in one, okay?